All right, welcome. Now I'm ready to go. Now, today we did circles yesterday in class. Now we're going to talk about ellipses, ellipse. Now, an ellipse is kind of an oval, okay, in the sense that it has two different radii. All right, so it has an x radius and a y radius. So the graphing form of the equation is as follows. Okay, we have x minus h, just like the circle, however, all over the radius, your x radius squared, plus y minus k over your y radius squared, and it's always equal to 1. And there's a relationship between the denominator of the radii and this number 1, and you'll see it later. Okay, now, there's multiple parts to this equation. Okay, there's the center, which is also HK, opposite inside, always focused on the numerator. We said your r sub x is your x radius, and your r sub y is your y radius. Okay, now, if your x radius is greater than your y radius, okay, we would call r sub x our major axis. Major axis. Sometimes you'll hear semi-major axis. So if your y is bigger, then that means your y radius is your major. Now, so the larger radius is our major axis, and then the other one is the minor. The other one would be your minor axis. So for instance, it's kind of hard to put it in context till you actually see what I'm talking about. So let's say this is your graph. All right. We would have, let's go here, then we'll put one all the way out here. So this would be my y radius because it's on the y-axis. This would be my x radius. All right, and then the same distance would be here and here. So the ellipse is kind of like an oval, kind of like a football. All right. So we're going to call A my length of my major axis. Length of major axis. And my B is going to be the length of my minor axis. Please make sure you're taking good notes. You're not just listening to me, because I'm going to check tomorrow. And then C is my focal radius. Okay, my focal radius. And how we find it is C squared is equal to A squared minus B squared. So in this case, my x would be my major axis, my y would be my minor, because my x is larger. All right, and then the C value, we say, is the distance from the center, I don't like how that looks, from the center to the FOCII. The foci, the foci, or the foci, depending on who you talk to, and I'll explain more about the origin of it tomorrow in class. All right, so I kind of just spewed out all the information you need. Now, we got to take an equation, put it in graphing form, and put all this information down. And as we go down, I'm going to keep referencing this stuff. So please, maybe keep these notes separate off to the side as you're working through the problem so that you have a reference. All right, so let's look at our first problem. Example 1, and we'll probably only do one problem because it's going to take a while. 25x squared plus 9y squared minus 200x plus 18y plus 184 is equal to 0. Now, we're going to do the same thing we did yesterday with the circles. Group your x's together. So we're completing the square to put in graphing form first. Group your x's, leave a little space. Group your y's, and then move your leave a little space, move your constants to the other side. Okay, now, yesterday when we were dealing with the circles, we always had lead coefficients of +1, so it was pretty easy to complete the square. We just divided the middle term, squared it, and added, and that was it. But now notice our lead coefficients aren't +1. So you have to take out the GCF, and it's not usually the GCF, it's always whatever number's in front of the x squared. In this case, it's 25, so I got x squared minus 25, 200 divided by 25 is 8x. And then over here, I'm going to take out my 9. Again, leaving a space because we know we're going to have to add something there. So y squared plus 2y equals negative 184. So 8 divided by 2 is 4 squared. I get 16. I add 16 here. What do I add to the other side? Well, 25 times 16. Okay, because you got your number out front here. Remember, it's got to be equal on both sides. So we're actually adding 400. Now with my y, half of 2 is 1 squared. So I'm adding 1, and over here, I'm adding 1 times 9. Sorry, I should be consistent. 9 times 1. Alright, so factor this. You got 25 out front. Then I have x minus 4 squared. And here, x plus 1 squared. Okay, again, we skipped that middle step there. We should be getting pretty good at completing the square by now. And then over here, negative 184 plus 400 plus 9 gives me 225. Now, notice at the beginning I said it is equal to 1. This piece is very important. All right, it's equal to 1. Is this equal to 1 right now? No. So we have to get it equal to 1. So how I do that is I divide everything by 225. And then we simplify. 25 over 225 is 1 over 9. So x minus 4 squared stays on top. And then the 9. Again, the 9 came from 25 over 225 is 1/9. So there's an imaginary 1 there, but we don't write it. Okay, so you want no coefficient in the numerator. Plus 9 over 225 is 1/25. So 9 over 225 reduces to 1 over 25. Put in your calculator and just hit math frac. It'll reduce it for you. Oop, and I made a mistake. This is a y. So y plus 1 squared over 25, again coming from here, equals 1. Now, you might think we're done, but we're not done yet. If you look up here, notice it's the whole term squared. The entire term squared. Alright, so you have to write this entire term squared. Now, the top's already done for you, so notice the denominator. Now, these are always going to be perfect squares if it's an ellipse. So that worked out well. So how do you write 9 as a squared? Well, x minus 4 over 3. Because 3 squared is 9. Then you do the same over here. Y plus 1 over 5. Alright, so now I can pull out all my important pieces. So now that we finally got the equation ready, we can graph it. I know it's a long video, but we're almost done. Alright, so my center point is opposite inside. So 4 is your x, negative 1 is your y. My radius of my x is 3. My y radius is 5. Therefore, this is my major and this is my minor. Now, that can change. Every problem could be different. Remember, the larger one is your major. So now we're going to calculate our c value, our focal radius, which we said is c squared equals a squared, which is the radius of your major, so 5 squared coming from here, minus 3 squared. So c squared is 25 minus 9, so c squared is 16, square root both sides, c is plus or minus 4. Alright, because when you square root. So your focal radius is 4. Alright, so let's graph this, and then we're going to go back and refer to that. All right, so here's my graph. It's going to fall in quadrant 1 and 4, so we don't really need that over there. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So plot your center. 4, -1. So your x radius is 3. So I'm going to go to the right 3. 1, 2, 3. To the left 3. 1, 2, 3. Then my y radius is 5. So I'm going to go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I missed one. All right, and there's your ellipse. All right, now, to find your focal points, or your foci, foci. All right, we have my focal radius. So that means from the center, you're going to stay on your major axis. So my major axis is my y-axis. So my focal points are going to fall on that major axis. All right, again, it's the largest axis, and it's 4. So from the center, you're going to go 4 units up. 1, 2, 3, 4. So let's call that F1. And then you're going to go 4 units down. 1, 2, 3, 4. So let's call that F2. Now, in this example, our focal radius is 9. A lot of times it's going to be decimals. So your foci, okay, you want the coordinates of those. Now on the graph, this one's easy to see. It's 1, 2, 3, 4, 3. 4, 3. But it's very important. Your minor axis will always match. Those coordinates will always match. All right, and then we went up from -1. So we actually, my y, I went up 4 units. -1 plus 4 is 3. Then here again, I have my 4, because I'm on that axis, so my x is the same. But this time, I'm going to go down 4 from the center. So down 4 will give me, well, down 4 from -1 is -5. So you can actually calculate it from your center point without looking at the graph. Whew! That was a lot of info, I know. I threw a lot at you, so it may seem difficult, but it's not. Tomorrow when you get to class, we'll do an example together. Make sure we're confident with this before moving on. So bring your questions, and I'll be checking tomorrow. Thanks. Have a good night.